The problem for this video is maximum product of three numbers. Given an integer array nums, find three numbers whose product is maximum and return this maximum product. The constraints in this question are the length of numbers can be between 3 and 10 raised to the power 4, and each individual number can lie between -1000 to 1000. Let's start off by looking at the brute force solution for this problem. So in the brute force solution, we will analyze the answer for every single triplet in A. That is, we'll choose every three numbers individually and see if the product of theirs is the maximum we have got so far. Here is the code for it. That is, first I will run from 0 to n minus 1, j runs from I plus 1 to n minus 1, and k runs from j plus 1 to n minus 1. At the end, we will use these three distinct indices of AI, AJ, and AK, multiply them, store them in a variable product, and if it is greater than the maximum we have received so far, we'll update the value of max. Initially, we'll set max as the product of the first three numbers. As we always have to give some product, therefore we'll just initialize it as any random value. That is any random product of three numbers in A. Now, if we use the given algorithm for the given array, we will see how it works. So for I equal to 0, j equal to 1, and k equal to 2, we will get a of I into a of j into a of k, which will be -3 into -2 into 3, which will give 18. So this will also be our current max value. So max will be 18. Now for k equal to 3, we will get -3 into -2 into 1, which will be 6. As it is not greater than the current max value, we will not update it. Now the value of j will update. That is I equal to 0, j equal to 2, and k equal to 3. Here the value will be -3 into 3 into 1, which will be -9, which is again less than the max value, so we will not change. Now the last one will be the triplet I equal to 1, j equal to 2, and k equal to 3, which will be -2 into 3 into 1, which will give -6. As this is also not the max value and the maximum value we found was 18, we'll return this in our answer. So what we're doing here in this brute force solution is we're taking every single triplet. First we took -3, -2, and 3. Then we took -3, 3, and 1. And finally we took -3, 3, and 1. -2, 3, and 1. Therefore, as we're analyzing every triplet and we're using two nested loops inside of I, the time complexity for this solution will come out to be big O of n cube. The space complexity here will be big O of 1, as we're not using any extra space except variable mx and variable prod. Now let's try to optimize this solution. Now to optimize this solution, let's think of what would happen if there were no negative elements in the array. Then the answer would obviously be the product of the three greatest elements. For example, in this array 2, 4, 1, 3, the maximum product will be the greatest three values, which is 4 into 3 into 2. And therefore, the product, we can find this product out by sorting this array. So we'll sort this array, which will give 1, 2, 3, and 4. And therefore, we can find our final product as a of n minus 1 into a of n minus 2 into a of n minus 3. But the problem is that we do have negative elements in our array. So let's try and sort this array that we have. It will give -4, -3, -1, 3, 5, 7, and finally 8. Here the maximum product will still be the product of the three greatest numbers, which is 5 into 7 into 8. But if this element at the place of -3 was something like -5 and this -4 was something like -9, then the maximum product we would get would be -9 into -5 into 8. We can see a trend here. To make the product positive, we either need zero number of negative numbers, or we need an even number of negative numbers, which is 2. Therefore, in our optimal solution, we have two cases. Either we take zero negative numbers or we take two negative numbers. Now, as we have divided it into two cases, we can individually calculate each of these cases, which is -9 into -5 into 8, and 8 into 7 into 5. This means the two least element and the greatest element, or the three greatest elements. One of these two will always be our answer. We can in each case calculate both of them. For example, this will give 360 and this will give 280. Therefore, our final answer will be 360. But there is one more case that we are missing. That is if all numbers in the array are negative. In this case, the answer will obviously still be multiplying the three greatest elements. That is the three elements having the least absolute value, which will be -1 into -1 into -2, which still falls under this case. So our final answer will be maximum out of a of 0 into a of 1 into a of n minus 1 and a of n minus 1 into a of n minus 2 into a of n minus 3. We can calculate all of this in O1 time, but we had also sorted our array before. Therefore, the time complexity of this algorithm is n log n, which is the complexity for sorting. The space complexity is O of 1 if we do not need to make another array, but if the array given in the question is immutable, that is the interviewer or the test tells you that you cannot change this array, you would have to create an auxiliary array which would require ON storage. While this solution is good and fast and it will work in most places, there is a solution which is faster than it, which works in linear time. The next optimization is we can do by storing values. As you may have noticed in the previous example, all we need is the maximum 3 values and the minimum 2 values in our array. To do this, we'll create a max array which has 3 elements which are all initially int of min. You can also set them to -1001, as in the constraints the minimum element possible can be -1000. Similarly, for mn, we have two integers in the array which you can set to 1001 or int max. Now, how this works is when we find a variable that is greater than the mx of 0, that is mx of 0 denotes the maximum element, mx of 1 denotes the second maximum, and mx of 2 denotes the third maximum element in the array. Similarly, int max, mn of 0 is the minimum element in the array, and mn of 1 is the second minimum element in the array. So if you receive an element that is the greatest you have ever seen, this is what happens. Say currently your max array is 5, second highest is 3, and the third highest is 2. If an element like 7 comes in, it is the greatest you have ever seen, which is in this case. So what you do is you store the value of 5 in an integer variable first or for. You store the value of 3 in an integer variable second or sec. Now you update the array as follows. You make the maximum element, that is mx of 0, a of I, which is the greatest element you have seen so far. Then you make the second element the previous greatest element, which is 5 or fur. And then the second greatest element now becomes the third greatest element. Therefore, this is the update you give for mx. Now, similarly, if the element you have seen is not the greatest, but it is the second greatest, that is elif a of I is greater than equal to mx of 1, then what you do is you store the value, let's say 753, and the next integer that comes in is 6. 6 will want to stay here between 7 and 5. So what you do is you store the value of 5 in a variable for, and then you insert it as 7. You make mx of 1 equal to 6, and then mx of 0 equal to 4, which is 5. Now let's say that the next element that comes in is greater than equal to mx of 2. That is, it is the third greatest element. You can also exclude this equal to part. So let's say the next element that comes in is 5 again. So what you will do is 7, 6, 5. As it is equal to, you don't need to do any operations. But even if you do operation that you replace this value by 5, it remains the same. Now for a similar array, let's say the mx array right now is 8, 6, and 4. Now if a value like 5 comes in, you straight away replace this mx of 2 by a of I. And this is how you maintain your mx array, which has the 3 greatest integers. Now let's see how the mn array works. For the mn array, initially, let's say both of them are 1001. So if any elements comes in, they will be able to replace this element as the minimum element. But let's say we have some elements -3 and 2 in our mn array right now. That is, this is the minimum element and this is the second minimum element. If an element like 0 tries to come in, what will happen is it will straight away replace mn of I. That is mn of 1. So -3 comma 0. But if an element that is the minimum you have seen so far comes in, for example -5, what will happen is it will store the value of -3 as for, like previously done. It will replace mn of 0 as a of I, and it will replace mn of 1 as previous for. Therefore, this is how you maintain the mn array, that is the two minimum elements in the array. Let's say this is the array we are provided as an input. So first of all, mx will be equal to -1001, -1001, and -1001. Similarly, mn will be equal to 1001 and 1001. So for I equal to 0, it will be the greatest element we have seen so far. It will replace this value of mx and the rest of the values will slide down. So mx will become 5, -1001, -1001. As it is the first element, it is also the minimum element we've seen so far. So mn will here become 5, 1001, as this element will slide down. Now for 4, it is the second greatest element we've seen. So mx is -1001 will slide down and it will become 4. And this will stay the same as these are both -1001. And it will also be the second minimum element we've seen so far. So we'll straight away replace this value with 4 for I equal to 1. For I equal to 2, 3 is the third greatest element we've seen. So mx becomes 5, 4, and the third element will be replaced by 3. As it is the minimum element we've seen so far, excuse me, this one was done wrong. 4 is the minimum element we've seen so far. So 5 will slide down and 4 will be set here. In the next, 3 is the minimum we've seen so far. So similarly, 4 will slide down and 3 will take 4's place. For I equal to 3, it is -5. As -5 is not greater than any of the elements in mx, it will not replace any value, but it is the minimum element we've seen so far. So in mn, 3 will slide down and the first position will be taken by -5. For I equal to 4, mx will stay again the same, but mn will change as -2 while greater than -5 is less than 3. Therefore, it will straight away replace 3 by -2. After I equal to 4, this will be the state of mn and this will be the state of mx. So for I equal to 5, as 1 is not greater than 3 or 4 or 5, it will not trouble mx. And as it is not less than -5 or -2, it will not trouble mn either. Finally, we have 4 as the last element at I equal to 6. 4 is greater than mx of 2, which is 3. So it will straight away replace the last element of mx, and the mx will be this. And mn now will be -5 and -2 still. This is the final state of mx and mn. Now our final answer will either be the product of mx, which is 5 into 4 into 4, or it will be the product of mn, into mx of 0, that is the greatest element, which will be -5 into -2 into 5. As we can see, this is the greater of the two, as this will be 50 while this is 80. But for example, if the minimum element in our mn was something like -10, then it would be -5 into -10 into 5, which will be 250, and hence this will be our answer. So we all we have to do is maintain the two minimum elements and two maximum elements, and then we can solve. Then we can find the product as either the product of mx or the product of mn into mx of 0. Therefore, the time complexity of this algorithm is big O of n, as all we're doing is running one loop from I equal to 0 to n minus 1. And the space complexity here is big O of 1, as we're using constant space. That is an array of 3 integers, another array of 2 integers, and some integer variable. Now let's try and code this algorithm. So here is the given code that was given in the previous slide. Now we'll see if it, now we'll try to follow it along for this given array. That is -5, 3, 0, 2, -1. So initially mx is as given, which is -1001 for all elements, and mn is 1001 for all elements. So we'll start off with I equal to 0. So this condition will be satisfied, then nums of I, which is -5, is greater than -1001. So now first will become -1001, which is mx of 0. Second will also be -1001, which is this element. And then finally, we'll replace the value of mx of 0 by -5. So after I equal to 1, mx becomes -5, -1001, comma, -1001. As the rest of the conditions are in else if, we will not follow these conditions. Now if we go down, we'll see the condition for mn comes in. Now for the condition of mn, what we'll do is we'll check if nums of I is less than mn of 0, which it is. Therefore, we'll now change the value from 1001 to -5. So it becomes -5, comma, 1001. And as we follow the similar algorithm, at the end, our mx will contain the three greatest elements, which will be 3, 0, 2, and our mn will contain the two least elements, which is -5, -1. As we had shown previously, this algorithm works to find out the two least elements and the three maximum elements, because that's all we require in our answer. Now let's see the final answer for this. So the final answer here will either be mn of 0 into mn of 1 into mx of 0, which will be -5 into -1 into 3, which will be 15. Or it will be mx of 0 into mx of 1 into mx of 2, which is the product of this array, which is 3 into 0 into 2, which will give 0. So our final answer will be the maximum out of these two, which is 15. Now, as I said, the complexity for this algorithm is big O of n, and as you can see, we have not used much auxiliary space. The space complexity here is constant, which is big O of 1. Now let's try and submit this code in LeetCode and see if it works. So this is the code mentioned in the previous example. So now we'll try and run this code on LeetCode. It gives the correct answer for the sample test case. So let's try and submit this answer. As we can see, the answer gives success, and it is faster than 87% of them, because this algorithm runs in ON. While the sorting algorithm of big O of log n works, this is the faster algorithm. And many times in interviews, if you give the sorting answer, the interview can request for you to optimize the answer further. So you should be aware of finding out how to find out the three maximum elements and the two minimum elements, and then subsequently finding out what the answer is for the maximum product of three numbers.